Hi everyone. I'm doing this little video to help you understand how to analyze marginal revenue and marginal cost, as you probably attempted it in your Thinking Like an Economist in the textbook and for your homework that I assigned previously. If you haven't attempted it, hopefully this gives you a good, head start into trying it in the future. So let's get to it. This is from Thinking Like an Economist on page 157 to 159. And for today, we're going to look at this, and for the test, we're going to only walk through the first part of this work, and we can revisit the rest of it, the monopoly scenario, at a later date if necessary. Take the time now to open your text on your computer and open the work that you've done on this Thinking Like an Economist work so you can follow through with what I show you. So at this time, I would say pause the video while you get all your stuff out. So as we know, to maximize profit in perfect competition, we want to equate or have marginal revenue greater than marginal cost. And if firms are all profit maximizers, as we are assuming, that they're all going to attempt to do this. And so we want to look for a point where we find that marginal cost does not exceed marginal revenue, because if it does, it will result in a lower profit making point. So if we look at our scenario, question one tells you to make a chart to determine what level to produce at. And so to do this, you'll need to use the information given to you in figure 7.14. And you also want to note that it says that the price charged per unit is $50. So every unit that is sold by this organization or this company is going to be $50 for the customer. So if we have all this information, figure 7.14 gives you total costs, and we have price per unit charged, we should be able to fill out the entire chart. Our chart should look something like this. So we will have an output column, a total cost column, a marginal cost column, a total revenue column, and a marginal revenue column. So the output and total cost section, that was given to you straight from figure 7.14. So if you copy that straight out, that should be fine. And the total revenue comes from them telling us that each unit cost or is sold for $50, and so that column is just by how many output there are times 50. So 0 times 50 is 0, and the 10 times the 50 is the 500, and so on and so forth. And so the next part of this, which is the difficult part, is to figure out what is marginal cost and what is marginal revenue. And so we know that marginal cost or revenue is just the additional revenue or cost from the next unit. So if you look at the total cost for 3, which is 125, and the total cost for 2, which is 95, the marginal cost for that third unit is the additional cost. And so it would just be the total cost of 125 minus the total cost of 95, which would give you 30. So the marginal cost for the third unit is 30. And so if you look at the rest of that column, you'll see 70 minus 40 would give you 30. 95 minus 70 would give you 25, etc., 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 all the way down to the 10th, which would be 520 minus 440, which would give you 80. So that's how you would calculate marginal cost. Marginal revenue is exactly the same way. In this case, it's very simple because each unit actually is sold for $50, and so the $50 revenue per unit is the marginal revenue. So if you see 100 minus 50 is 50, 150 minus 100 is 50, so on and so forth. So that would be a relatively simple scenario. It is good to note, though, that not all scenarios are like this. Some scenarios may have marginal costs being consistent and marginal revenues not being consistent. So I would say that when you get to the graphing point, that you want to ensure that you are reading your data and you're not assuming anything looks like something you've seen in the past. So make sure your data is correct and to graph based on your data. Going on. And so if you look at our scenario here, I've just expanded what you see the output from the third to the 7th or 8th unit, the costs and the revenues. And so if you see here, you have output on the left-hand side all the way to marginal revenue on the right-hand side. And this is just the, a magnification of that excerpt. So we want to find out, where do we produce, or how many should we produce? And so our profit maximization criteria is to locate where is marginal revenue greater than or equal to marginal cost. And so if you look at the marginal costs, which is the middle column, you'll see 30, 35, 40, 45, 55, and 65. And then if you look at the marginal revenues, you'll see that they're all 50. And so where does marginal revenue exceed marginal cost? Well, you'll see at 45, marginal revenue is exceeding marginal cost of 50 versus 45. And then if you look at selling 7 units, you'll see that marginal revenue of 50 is less than marginal cost of 55. And so you'll see at 6 units, we are satisfying our scenario where marginal revenue still exceeds marginal cost, whereas at 7 units, marginal revenue does not exceed marginal cost. Therefore, we sell up to 6 units to maximize profits, because if we sold that 7th unit, we'd actually lose $5 and our profit would go down. And so in this scenario, we would want to sell only 6 units. Hopefully that's clear. If we just always utilize this methodology in terms of profit maximization, we should get the right values. All this information is good in a chart format or in a table format, but maybe we want to graph marginal revenue and marginal cost. It doesn't tell you to do this in your text, but I would like you to attempt this because this is going to help you visually see what's going on. And so if we graph marginal revenue and marginal cost, the two red columns, we will get a graph that looks something like this. And so you'll see that marginal revenue is the blue line, and it is consistent at $50, where our x-axis is output and our y-axis is amount of dollars. And so marginal revenue is always 50, so that's why it's a straight flat line. And while marginal cost is a upward sloping line, as you can see. And so you'll see here that marginal cost is lower than marginal revenue for the first half of the graph, I should say, and the second half of the graph, marginal cost, is greater than marginal revenue, which would depict losses. And so if you see here, you look at all the vertical lines I've just placed for you. Each of these lines represents the output level. So you'll see the furthest left line of 1, where marginal revenue is 50 and marginal cost is 30, and so on and so forth. And so you'll see where our decision point happened between 6 and 7 units. So at 6 units, you can see the blue curve is greater than the gray curve still. And then at 7 units, the gray curve is now greater than the blue curve. And this represents a situation where there's a loss. And so our choice in this scenario is to produce only 6 units, because if we go beyond 6 and get to the 7th, we get into loss territory. And so this graph depicts our profit-making scenario, whereas wherever the marginal revenue is greater than the marginal cost, that depicts a profit. And so we see here that all that blue shaded area is our profit. But you can see this little triangle between 6 and 7 where at our 6th unit produced and sold, it is still before the intersection point where marginal revenue equals marginal cost. And because of that, we're actually not realizing our maximum profit, because we haven't been able to actually equal marginal revenue to marginal cost. If you remember previously, the marginal revenue was $50 and the marginal cost was $45. So they did not equal. If there was a scenario where maybe that would be 6.5 units or something like that, we would be actually able to maximize even more profit in this scenario. I hope that makes sense. Of course, if you have more questions, you can clearly send me some messages or ask me